Hello everyone, my name is Raj Jain. I'm a software development manager here at Amazon, and I'm going to describe a solution architecture where we will discuss how we can enhance the security of AWS App Mesh deployments with mutual TLS, where the certificates for mutual TLS are managed by ACM PCA. So as we cover this topic, let's discuss some basics. AWS App Mesh is basically a service mesh based on the open source Envoy project. And what AWS has done is they have offered a custom Envoy container image as well as built a managed control plane for the App Mesh network. So that's what the AWS App Mesh service is. And as we know, for any service mesh products, basically the traffic within these app meshes is described as east-west traffic, which is in contrast with north-south traffic that we discuss when we discuss external-facing APIs or client-server communication. East-west traffic basically refers to a bunch of microservices deployed in a given service mesh, and then these services are connecting with each other for various business workflows. And not every service should be connecting with everything else. I mean, there is a security problem if that happens. That's the kind of problem service meshes solve in general. And by adding mutual TLS to the mix, we can enhance that security even further. So the mTLS or mutual TLS, basically what it does is it adds this bidirectional authentication property between two communicating entities. Basically two microservices in a service mesh network. And in contrast with one-way TLS, in which the client authenticates the server sends client its own certificate, which the client has been pre-configured to trust through the CA chain of that certificate. Now that authentication is only unidirectional because only the client authenticates the server. But with mutual TLS, what we do is we do a bidirectional authentication where, in addition to the client authenticating with the server will now authenticate the client. So the TLS handshake protocol runs a little longer. At the end of the client getting the server-side certificate, the server turns around and basically asks the client to provide its own certificate. And only if the server trusts the client certificate, that's when the mutual TLS exchange will come into existence. So we will deploy mutual TLS concept in AWS App Mesh, but as with any certificate deployment, certificate management is a complexity, and for that we will use ACM Private Certificate Authority to actually issue certificates and use that as a managed PKI for managing the certificates in App Mesh. Now, the communication inside the App Mesh is basically doesn't require external public certificates. So what we need to have in App Mesh mutual TLS exchange is basically private certificates. And for that reason, the ACM Private Certificate Authority is a perfect fit for actually getting those certificates managed within the ACM PCA and then getting them deployed into the App Mesh and kind of take care of all of that complexity for us. So the system that I'm going to describe is a simple system with two communicating entities which will engage in a mTLS exchange where the certificates are derived from ACM PCA. The two entities are basically known as color gateway in my examples and color teller. And customers who are familiar with App Mesh and the AWS GitHub projects on App Mesh will know that the App Mesh examples have consistently used this pattern, a color gateway and color teller design, to walk customers through various kinds of examples. So I'm going to stick with the same pattern and use the same example to demonstrate this solution. So I'm going to walk us through a detailed overview of what the solution architecture is, and then walk us through the AWS Management Console to show how the ACM PCA and App Mesh have been configured. And then I'll close with a small demo where I will actually send a request from the outside into the mesh, and we will see how an mTLS exchange happens, and we can prove it by looking at Envoy statistics. So let's dig deeper into the architecture. So To set up the system, what we will do first is we will create two independent certificate authorities. The first certificate authority shown here is the color gateway certificate authority. And as you can follow the notation in this diagram and the color scheme, what you can see is that the the chain here is basically comprised of the root CA certificate for the color gateway and one endpoint or end entity certificate that will sit within the Envoy proxy for that color gateway service node. Likewise, we have a color teller certificate authority which has a root CA and an endpoint certificate derived from it. The best practices for creating certificate hierarchies is to use intermediate CAs and not directly issue endpoint certificates from root CAs, but for the matter of explaining and for simplicity, we have chosen to derive endpoint certificates from the root CA certificates directly. So the idea behind also choosing two independent certificate authorities is to fully demonstrate how, if the proper configuration is achieved by configuring the certificate chains within the respective components, we can actually do a full TLS, mTLS exchange and demonstrate that these are two independent root CAs basically. So step number 1 and 2 is basically showing AWS Certificate Manager and ACM PCA configured with two certificate authorities and two endpoint certificates. Now, what happens is when the system is being configured, and we have shown all of this code in our GitHub repo, which the link of which exists on the next slide. As the system is coming up, the AWS, there is a Lambda function. What that'll do is that'll be responsible for actually extracting the client-side certificate from the ACM PCA and ingesting that into AWS App Mesh. Now, the server-side certificates are actually natively integrated between the App Mesh and the ACM, so we will not need to kind of dig into that because that's a native integration. What this solution architecture really describes is how to integrate the client-side certificates and kind of complete the picture when it comes to mTLS exchange. So in step number 3, what this Lambda is doing is it's basically talking to Secrets Manager over a simple API called getRandomPassword. And the whole idea here is to get a random string with sufficient entropy and a sufficient policy meaning, how many characters we want in the passphrase, and a mix of alphabets and special characters and numerals. So once we get that, basically what we will do is we will use this passphrase to export the client-side certificate from the ACM. And we will provide this passphrase to the ACM so that ACM can actually package up the public material, the root CA, for example, and the endpoint certificate for the color gateway. But since we also need the private key for actually running the TLS stack inside the Envoy, the private key will need to be transported from the ACM into the App Mesh secret in a confidential fashion such that none of these entities actually get exposed to it. So what the ACM will do is it will encrypt the private key with the passphrase that we have provided, and that comes back from ACM in step number 5 that the root CA came out, the endpoint certificate of color gateway came out, and the private key for the client certificate is exported in an encrypted fashion. So the next thing that the Lambda does is it stores this information into AWS Secrets Manager. Because we are dealing with a passphrase and we need to maintain confidentiality over it. So AWS Secrets Manager serves as the right service for handling that information. Now, as the service mesh is coming up, it will then begin to talk to AWS Secrets Manager because of a custom startup script that we have placed in the Envoy proxy container. And it will also begin to talk to AWS Certificate Manager. Now, one thing to note here is that ACM has certain rate limits on how many export certificate API calls it can accept. And that number is 5 transactions per second. So ACM can accept 5 transactions per second export certificate calls. So that means if you have a 100 node app mesh, expect that to take 20 seconds for all these certificates to get exported from ACM and ingested into the app mesh Envoy proxies. So That's just a word of caution for people who are designing very large meshes. So be aware of this limitation that this much time can be spent in bringing up the system for the very first time. This delay is only at startup. It doesn't translate into runtime delays or anything like that. So in step number 8 and 9, what's happening is the Envoy proxies are coming up and they're retrieving their server-side certificates through the native integration from the ACM. So if you follow the color coding of the certificates that are moving into these proxies are shown by the color. For example, in this case, the color gateway is getting this blue root CA, which is actually the color teller's root CA, because at some point we need to trust that certificate during the TLS handshake. And so after this, the system is basically up and running. And you will see in the demo that I have later on in this presentation that we will send a request into the color gateway from the outside, a curl request basically. And what that will do is it will initiate basically the TLS handshake from the color gateway Envoy proxy to the color teller Envoy proxy. So in the first part of the TLS handshake, we will see the server certificate coming back to the client. And in the second step of the TLS handshake, because this is a mutual TLS setup, we will see that the server is asking the client to provide its own certificate, which comes over onto the server. And only when that exchange succeeds, that the mTLS session will come into existence. And we will then basically run a simple HTTP request on top of that mTLS session that has been established through this step. Now let's talk about certificate renewal. So a complex issue in certificate management is certificate renewal. And what makes it even more interesting is that how do we do certificate renewal without any downtime? So ACM has a mechanism through which it can actually send events to CloudWatch long before a certificate is approaching expiration. So in step number 1, what we do is we pick up this event from the AWS Certificate Manager and bring it over to CloudWatch. Now in CloudWatch, what we do is we define a custom trigger, which is basically a Lambda function, also part of the GitHub AWS open source project. The link is shown here on the left. And this Lambda function, what it'll do is it'll basically renew the certificate with the ACM, export that renewed certificate, bring it over and store it in AWS Secrets Manager. And then it'll basically trigger the ECS because our app mesh is running inside the ECS Fargate containers. It will trigger the ECS basically for a blue-green deployment, so that basically whatever containers are running and handling requests can retire gracefully. And as new app mesh nodes are coming up with new Envoy proxies starting up, they will go and fetch their server-side certificates from Certificate Manager and the client-side certificates from the Secrets Manager. So with that established as the architectural overview, next thing I will get into is a AWS Management Console walkthrough and a small demo.